We'll be limited to one board since we got my camera in here, but maybe they should have my camera fixed up in that room for us Thursday. We won't have to drag all this in there every time. And we Tuesday, Thursday? So the goal was we got 24 people in here, and it was to split it 12 and 12 each class. But I don't really get 12 that show up every time. So if any of y'all really need to come both times, you can do that. And so Thursday, if you don't come in here, you'll get online on Zoom, and you'll just be online with me. Okay, but y'all still ask the questions through the Zoom and everything. Okay, so yeah, until we get it going. So hopefully the COVID will go away, and everybody can be back in class, right? Maybe. You don't like it online better or in class? Online? Well, well, I wouldn't mind online either, but it's like when I get online and I'm teaching, and I'll be like, okay, you got any questions? Don't no one ever say nothing. So it's like I'm just talking to myself, you know. So see here, I got all that in front of me, right? All right, so we're gonna get into chapter 2, A, B, and C. And you're going to notice this class skips around a lot because we just want to touch base on a lot of different math concepts, but not necessarily dive into them really deep, like we were talking about. So first thing I'm going to look at is a 3-step problem-solving method. Okay, so probably the most important thing, number one, understand the problem, right? What are they looking for? Okay. All right, so once you understand your problem, sort of figured out what you might be looking for. Last name. Reed. Reed. Logan. All right, second thing, once you understand that problem, you're going to solve the problem. And then the third thing, explain your result. Does it make sense? Did I answer actually what they wanted me to answer? All righty, so, what's that last name? Harris. Harris. Okay, Brandon. Take one of these. I just backed up my camera, y'all. Get that thing. All right. We're getting close to the max, ain't we? All right, so we're going to review first before we actually start solving these problems. We're going to review some fraction rules and a few exponent rules. Y'all remember how to add and subtract your fractions? Multiply and divide? So let's do some fraction review. Okay, truthfully to me, with fractions, the easiest thing is probably multiplying fractions. Dividing would probably be next, but all you gotta do is flip them and do stuff. Adding can be easy or it can be hard. depending on whether I got a common denominator or not, right? I got a common denominator, fraction's not bad to add. So if you don't, then you gotta try to find common denominators and all that fun stuff, okay? So, we're gonna play with the adding and subtracting first. Okay, so let's play one of these. I'll start out with 1/5 plus 2/5. Well, that wouldn't be bad, would it?
1/3. 1/3.
What do you think?
1/3.
1/3? So how you getting that?
No, I didn't know, but it's not an even number. You're right.
Mhm.
So it's 3/10.
What did you just say?
3/10.
3/5. Or you say 3/10?
I don't know.
3/5? 3/5, right?
Yes.
So the thing about when you add a fraction, if you got a common denominator, no matter what, that's gonna have that common denominator,
Oh,
right? Because you got things split into fifths. So what you're gonna do now is just add, you have 1/5 over here, you have 2/5 over here, but they're still in fifths, right? So remember on fractions, once you got that bottom denominator looking the same, all the stuff is gonna get done on top as far as the adding and the subtracting, okay? So we'll just come across add to 1 plus 2. So technically you would be doing that. Right? And then that would give me what, my 3/5. And one thing about fractions, when you're done, you always want to see if you can maybe reduce them to get them in what we call lowest terms. But 3 and 5 have nothing in common. So I would know that'd be the farther if I could go on that, okay? But watch out, if they do have, like you got something like 4/6, you would have to reduce that kind of stuff because they would have 2's in both of them, right? Same thing other than we're subtracting this one. But I do know the bottom number is going to be a number. You know, they got a good calculator would be like a TI-83, TI-84. Those will knock out fractions really quick. And then you got a button on there you can hit and turn the decimal back into a fraction to get the final answer. Okay? So this one's going to be what? 5/9. Say again? You got to have to, yeah, if you're going to reduce that, it has to be both of them numbers. So let me show you something that you would reduce. So say I was working one of these, and I'll show you what I would have to reduce one. How about if I had 5/12 plus 3/12? So what's going on top?
8.
So I know it's going to be 8/12.
And then you have to reduce those.
This one definitely has to reduce.
Reduce them by 4.
We want to reduce it by 4. So what you want to do is, now you could have started with a 2 because you knew them were even numbers. But if you divide by 2, you still have a 4/6, which means you got to divide out the other 2. So if you're good at knowing your factors, 4 would be the largest factor in here. So to reduce this, I would basically divide both them by 4. Because when you divide something on top and bottom by 4, it's like you're really dividing by 1. So you're not changing what we call the value of the fraction, you're just changing the way it is. So if I got that out, I know what I'm going to get.
2/3.
You'll say 2/3? That's what's nice about the calculator. If you added it on there, it gives you a decimal. So when you turn the decimal back into a fraction, it's gonna give you the 2/3. It's not gonna give you the 8/12, because it knows it's gonna reduce it to those terms for it, okay?
What is it that you hit to create the fraction? It's like second something.
To reduce them, I would hit,
Yeah, on the T layer is second something.
oh, how about this, math and enter twice.
Oh, okay.
So it'll give you
Been years since I've
decimal, you hit the math button, it's on the left side of them calculators. And the first thing it brings up, it says arrow fraction, which means it's turning your answers back into a fraction on that, okay?
Okay.
All right, let's turn it up. Okay, 1/2, so I say 1/3. Can you add any way, look? No, 'cause I can't add halves over here to thirds. So this one, I actually gotta find me at least common denominator. And it definitely would be a 6. So if you're not very good at finding a common denominator, if nothing else, you can multiply them bottoms together and get you a denominator. And that's basically what we did on that, right? 2 and 3. Really, if they're prime numbers like 2 and 3 are, the only way to get the denominator is to multiply them together, okay? But what if I had a 6 and a 12? Would I want to multiply a 6 and a 12 together to get my common denominator? Because one of them numbers would be the common denominator, right? So on that, I would go to 12. Because you want to find a number they can both go into for that denominator, okay? So LCD is a 6, right? So y'all, since LCD is a 6, I've got to turn both of them into something over 6. So the trick is, whenever you multiply 2 by to turn it into a 6, you got to multiply the top by the same number. So since this was what 2 times 3 made 6, I would do 1 times 3 and make that a 3/6. Okay? And 3/6 is still a 1/2, right?
Mm-hmm.
What about this? And you got a 1/3. What would that turn into?
2.
So that'd be a 2/6. Good job. So now look, we do have the common denominator. So I know on bottom will definitely be the 6. And on top, I'm going to put my, there you go. And I'm pretty sure that ain't reducing, right? So questions on that? So let's do more. I guess that's a good thing about the calculator. It don't need a common denominator. You just throw in them fractions, it'll add them. It knows to do all that for us, right?
Mm-hmm.
All right, y'all, so let's try a 4/5 minus 2/3. So give me LCD.
15.
So 15 again on this one, okay? So I'll do one in a second. That'll be a little different instead of just multiplying them. But you can always multiply them. The only thing is sometimes when you multiply them, you get a really big denominator and a really big numerator, so you're going to have to reduce it eventually. So I need to turn these into 15s. So the 4/15, what would y'all put that as?
12.
You say 12?
16.
All right, what about the 2/3?
No, I can't think. 12.
6. So I give you what, 6/15? So I do now have that common denominator, right? So I'm gonna go across here. I know this will be something over 15. So 12 minus 6 gives me what, a 6/15.
No.
Oh, you're really close.
I'm so close. I'm so close. I know it. Three fifths. It'll be 3 fifths.
You're so close.
Oh, 2 fifths.
So, there you go.
Yeah, I was thinking like it. Yeah.
So 2 fifths, so she was trying to get them threes out of there. Does that make sense, y'all? Now, like I said, if we could reduce them, put 6 divided by 15 in the calculator, math enter, and return that decimal back into a 2 fifths. Okay? So these bringing back memories, I hope, right? All right, here we go. Let me think of a number here. How about a 7? Oh, what I want here? I want an 8. I'm gonna add that to 3 over 24. So definitely need a common denominator. But y'all, hopefully, we don't want to multiply 8 times 24. That's gonna be a really big number.
So let me just do 24.
I can use 24. So if the smaller number, the 8, is a factor of the big number, which is 24, 24 would be the least common denominator. They both go into 24, right? So we're going to turn both of these into 24. What's nice, I don't even have to change that second one, do it. It's already got a 24 on the bottom. So 7/8 becomes what over 24? 21. Okay. Now what's going to happen? What's this? I know the bottom 24. Well, hell, what's the top?
24.
24 also, right? 21
That's
plus.
gonna be
Can you reduce that to a
1.
1?
1.
There you go. Okay. It's usually the last thing I look at on my fractions. What can it reduce? Now in here, if you ever get a fraction that's bigger on top than it is on the bottom, you don't have to worry about turning it into a mixed number. So leave a 9/7 as a 9/7. You don't have to do what 1 and 2/7 and all that. Okay. Leave them as an improper fraction.
Why does the 3 stay the same?
Oh, because when I was finding my common denominator, since I knew 24 was my common denominator, I didn't have to change this fraction at all. So I just brought it down and it stayed 3/24. So you really only got to change that top number if you have and change the bottom.
So that one, like, it was already done.
And that's a trick on them. Well, that would have been big if I would have had multiplied that 8 and 24. You know what? That's bigger than our Arkansas math, so, right? Y'all go to school in Arkansas? So here's Arkansas math. What's 12 times 12?
24. No, 144.
Okay, 144.
Stop.
We call that Mississippi math there now.
Oh my God. So terrible.
So what's 13 times 13?
Oh, there you go.
I stumped y'all on that. The Arkansas puts it what? 12 times 12.
Is it 156? Well, it's 1 something. I don't know.
136.
Oh, it's bigger than 144 for sure. So 13 times 13.
I ain't touched it.
See, that's the difference in all the states. Arkansas puts it 12 times 12. Mississippi probably puts it 10 times 10. New York then probably goes to their 20s, you know. Go where I went to Arkansas too.
What school?
Comments,
Where is it?
Little Rock Mills.
Ew.
No.
That's not sick.
So any McClellan people in here? Anyone from McClellan? That was our enemies back then.
I'm making a whole lot this year. Like, Mills is doing something in basketball for some reason. I don't know.
No, it is do that, yeah. When did you get back in our day? All right, y'all, so we're gonna get into multiplying these fractions now, which to me is easier. Hopefully, right? So we'll say this, when you're multiplying fractions. So when you're multiplying fractions, if I had something like A over B times C over D. And y'all watch the math of that. Sometimes they'll put the X there for multiplying, and then sometimes they'll just put that dot there. Sometimes they'll even put one number in parentheses and one without parentheses. So every which way you learn multiplying, they hit you with that sometimes in the math lab, okay? But to me, fractions is easy because you multiply the top times the top, and then the bottom times the bottom. So we multiply straight across. Okay. What if a number don't have a bottom? So what if I had something like A over B times C?
You put a 1 over it.
Bam, I put a 1 under it, right? Now you would still put a 1 under it. Because what happens if people don't do that, they'll multiply both of these times to one number, and that's really messing it up, okay? So if you can multiply, then you should be able to divide. Because when you're dividing fractions, so say I had A over B divided by C over D. Well, sadly, we don't like to divide fractions. So y'all remember, I'm going to change that thing to multiplication, right? So I'm going to change this to A over B times
C over D.
D over C.
D over C. Remember, you got to
Gotta reverse.
flip the fraction. There you go. Good job. So now it's multiplication just like the multiplication was, right? So just remember, on dividing, it's never the first fraction. You leave it the same. Change it to multiplication, and then we call it reciprocals or invert it, flip it, whatever you want to call it, right? So that the final answer becomes the A times D over the B times C. All right, so let's play some of these. All right, y'all, so I forgot what number I'm doing, so I'm just going to do 1/3 times 2/5. Now, I'm going to show y'all a trick that I use as far as knowing whether these fractions are going to reduce or not. I look at these two numbers, the 1 and the 2, and I see if they got anything in common with the bottom numbers. But a 1 and a 2 really don't have nothing in common with a 3 and a 5. So since those have nothing in common, I know when I'm done, I got my final answer. Okay? And I'll show you one when I'm talking about being able to do the reducing I'm talking about. So on that multiply me straight across, and I end up with 1 times 2 is 2, 3 times 5 is
15.
15. And a 2 over 15 will not reduce, okay? So I'm going to show you one that I was talking about. So what if I had a 2 over 7 times a 3 over 10? This is going to reduce because that 2 and the 10 have something in common, right? Yeah, that's it. Perfect. So there's two things you can do on these fractions. You can reduce it before you multiply, or you can reduce it after you multiply. A lot of times it's easier before, because then you don't have really big numbers you're trying to look at. So let me show you what I'm talking about. The 2 and the 10 both have a 2 in them, right? So I'm going to divide out the 2 and divide out the 2. And it looks like I'm going to get perfectly what you said, right? He multiplied straight across and got me what? 1 times 3 was 3. 5 times 7 was 35. Now notice, had I not reduced that, I would have ended up with what? 2 times 3 was 6. 7 times 10 would have been a 70. To me, it's harder to figure out that 6 over 70 versus that 2 and that 10. But still, you take out 2 and still get a 3 over 35, okay? All right, questions yet?
No.
3/4 times 5/3. So that would reduce. Now this one, I'm just going to do this and I'm going to multiply and then do that. What would you reduce? 5/1. So you would take them 3s and pretty much just turn them into a bunch of 1s, okay? So we forgot to do that. So we multiplied straight across and got a 15 over 12. But no, what? I'm still going to reduce it by what? Mm-hmm. So divide both of them by 3s. I get what, a 5 over 4. Same thing he said a while ago, right? He turned them 3s into 1.
About like the bigger number on top.
Oh, that's what I said a while ago. Leave it like that in our math lab.
Okay.
Now, they made y'all do what we call mixed numbers back in the day. And unless it specifically asks you to do a mixed number, just put them in there like it looks. Okay? But do y'all know how to turn that into a mixed number? Mm-hmm. So here's the trick. If you did want to turn this into a mixed number, you'll see how many times does 4 go into 5? 1 time. So that'd be 4 times 1 would be 4, right? Now to get the top of your fraction, you subtract that 4 from that 5. Right? So 4 from 5 would leave me 1. So that's going to go on top of your fraction. And then the bottom is always the same as the bottom was when we started. So I started with a 4 on the bottom. This will have a 4 on the bottom. So you see how many times that number goes into the bigger number, and then whatever is left over is the top of your fraction. Now, if I wanted to convert it back, 4 times 1 is 4, plus that 1 is 5, and you put that 5 all over the 4. But only we'll make y'all do all that kind of stuff, okay? It's not hard. All right, here goes a little division. So y'all, how about a 10 divided by 1/2? I would probably put a 1 under the 10 if you wanted to. So basically, this question's asking me, how many halves can you get in a 10? Perfect. 20, right? Half and a half is 1, another half and a half would be 2. That's what this is basically saying. So we're going to go back and do what? 10 over 1 times. We're going to flip the second fraction, make that a 2 over 1. And I get what he said, right? 20 over 1, which will be a 20, okay? So flip that second one, and then you're just multiplying straight across. Okay. So let me explain. One thing that I cannot do to this. You remember over here, we were reducing these numbers and stuff? Although it looks like I got stuff that's gonna reduce, we cannot do that while we're dividing. We've got to get it switched and start multiplying before we can start trying to cancel and reduce, okay? So my first move on this was to turn this 3/4 times, put that second fraction to make that what, a 5/2. So look, does anything reduce? Because I don't have, my 3 don't reduce with the 4 and the 2. That 5 won't reduce with the 4 and the 2. So nothing's going to reduce. So we're going to multiply straight across. 3 times 5 is what, 15? 4 times 2 is
8.
okay. Right, then leave it be. Now, watch this one. If I was going to turn this into a mixed number, just to give y'all more knowledge on this, how many times does the 8 go into a 15?
1.
One time. Which would be 8, right? So now you subtract that 8 from the 15 leaves you.
7.
So my top number would be the 7, and the bottom number we said would have to be the 8. There you go, okay? But they're not going to give us like that, like I said. All right, so I guess in order to be able to solve problems, you got to know what they're asking for. So here we got, whoops. So words used in math. So I'm going to come up with words that mean add, subtract, multiply, and divide. So to add, the big word we use in math is sum, the sum of two numbers. What about, have y'all heard of a word like in shopping? When you go to the checkout and they add all your stuff up, they call that the total. A total, right? So a total means you're adding stuff up. What about more than? I got 5 daughters. Well, you don't call that more than. Oh, and then you can also go with plus, added to, all them fun words. Which one? Addition. Mm-hmm. Subtraction, the big one we use in math. Minus, that's the second big one. This one starts with a D, difference. That's, I always try to use them fancy words to mess with you, like sums and differences, okay? Less than. But the big one is the differences in the minus. Equal to? No, but we'll add that up here. For the equals. We'll put that on there. So when you got equations, you got to worry about what might mean equals, right? Multiplication. Product is the big one. Multiplied by but there's one word that means multiplication and it's only 2 letters. Oh, dang, perfect. Right? Of means multiplication. I got 1/3 of a dollar. You would multiply that, okay? Division. Quotient, that's the big one in math, what it is, quotient. And then you got all that stuff like divided by, ratio. Y'all heard of a ratio? Compares two things, that's like division. What about per? Like miles per hour type stuff. That's why the big ones on that. So equals, there's a 2-letter word that means equals.
Is.
Man, is.
I mean, is.
Huh?
So I mean, is.
Is.
Didn't mean to say that in question form.
Is equal to, amounts to, solution, all that kind of stuff, okay? So they like to kill you with this one in this section. I think they even got a question in that lab that asks what which one would mean to multiply or something. So. All right, y'all, so one more thing before I actually get into doing the unit conversions, I'm gonna play with some exponent rules for you. Because eventually we're going to get into what we call scientific notation, which is like 2.5 times 10 to the something, okay? So let's go over a few exponent rules. And there's only one they're really going to hit you with in here, okay? So x to the a times x to the b. If my bases match, which is what the x's are, when I multiply, if my bases match, I'm going to do something with them exponents. But what do you mean by combining?
Like, just X, A, B. What do you, X, A?
You're really close, but if you did AB, would be multiplying them. I'm gonna
Add them?
add them. So that this would be x to the a plus b. Okay? Just like if y'all was doing algebra back in the day, you did an x times an x, y'all turned that into an x squared. So you took 1 plus 1, and that made a 2 on that. So good job. All right, so let me find my little examples over there. All right, so they're doing stuff like this. 10 to the 7 times 10 to the 3rd. Now, the reason they like using these with exponents, if you was to write out that 10 to the 7, that would be a 1 with like 7 zeros behind it. That's like big, okay? So we use scientific notation so we can write it basically in what I call shorthand style, okay? Because millions get big and trillions and, well, I skipped the billions, I guess, but the billions and trillions, they all get big, okay? So remember, them exponents are basically telling you how many zeros they got. So what's this final answer then? So remember, the base comes over, and then what do you do with them exponents?
Just
Oh, did you just multiply? Okay, she's multiplying it. So y'all remember, add those exponents. There is a time in life when you would multiply them, but that would be if you had something like this.
No, you're right.
And then you would, hopefully. But if you got an exponent to an exponent, then you would multiply them. But when you're multiplying the bases, like 10 and 10, if they match, you just add them exponents and be done. Okay? All right. 10 to the 4 times 10. Oh, hell, let's go negative. But I know it's going to be a 10 down there, right? So the question is, what is a 4 plus a negative 2?
2. No.
What'd y'all get?
You would need to turn that -2 into a +2, won't you?
Oh, no, I don't even got to do that.
Okay.
So I'm just going to add 4 plus the -2,
Which is 2.
which is definitely 2. So I got me a square on that. So let me tell you the trick on, if you are having to add unlike signs, you take the larger number, which is the 4, subtract the 2 from it, and you get a 2. Then you give that answer the sign of your larger number. So since my larger number was the +4, that kept my 2 positive on that, okay? So let me do one with a big negative here. How about 10 to the -9 times 10 to the 6? All right, y'all, 10 to the -9 times 10 to the 6. It's going to give me 10 to -3. So notice, unlike sign, so I did 9 minus 6 was 3. Larger number was negative, so that made my exponent negative. Now, I'll tell you, technically,
Can't
we
have a
wouldn't want
negative.
negative exponents in our final answer. So we would have to flip that and make the exponent positive, but we're not worrying about that in here, okay? All right, so my second rule, what would I do if I had a fraction with an x to the a over an x to the b? I would take the x and do what? A minus b. So take that top exponent and subtract the bottom exponent. Make sure the bases are the same though, okay? You can only do that when those numbers match up on the bottom.
Can you repeat that, Mr. Rathon? You said what now?
You always take the top exponent and subtract that bottom exponent from it.
Okay.
Yeah, because they're not doing no tricks in here too much for y'all, okay? I mean, in algebra, I make the bottoms bigger than the tops, and they got to do different things, but we ain't gonna have to do it here, right? All right, y'all, I got a 10 to the 9th divided by 10 to the 3rd. So that would definitely equal 10 to the something. Six. All he did was 9 minus 3 got me a 6 on that, okay? Now, y'all, it's not too bad when you got nice whole numbers up there that are positive. But y'all, I can do this. 10 to the 5th divided by 10 to the -3rd. Damn, he's pretty good, ain't he? There's your study buddy right there. Because remember, 5 minus a -3, right? But I got a double negative there, so you are used to making them into a big positive, right? But he said 5 plus 3 got me a 8. Oh no, if I flipped them, then I would have to change the sign. This would become a +3, this would become a -5. Now, I really wouldn't want to flip that one, but let me show you what you could do to this. Okay? So the other way to do this, I got a 10 to the fifth over 10 to the negative third. If you move one of those up or down, you change the exponent sign only. So watch what I could do to this. I could bring over that 10 to the fifth. I could move this 10 to the negative third from the bottom to the top. If I do that, I change the sign of the exponent only. But now you got a 10 to the fifth times a 10 to the third, right? So what would you do to that?
I was like wondering, like, when I was talking about the negative thing, are we not doing like I thing?
The eyes?
When it goes negative.
You know where you got the eyes from? So y'all, this ain't part of this math, but you got the eyes from doing this stuff.
Mhm.
Are we not doing?
Well, I can bring it out if you want to. Those are what you call imaginary numbers. So imaginary numbers, can you take the square root of a 4? What times 1 is 4? 2. Also, you could do is negative 2 times negative 2 would be a 4. So square roots can be 2 positives or 2 negatives, right? Can you do that with a negative 4? Because 2
No.
times 2 is 4. Negative 2 times negative 2 is 4. You can't multiply the same sign times itself and get me a negative 4, okay? So I won't go into that, but since we can't do this in the real world, this would be what we call a 2i. But yeah, now if you did this on this, you'd have a 10. If you're multiplying, you would add that and still get a. So, but me, I'd probably just 5 minus negative 3, make that an 8 and be done with it, okay? All right, so that's all the exponent rules they're really going to kill us with. Well, let me see. Well, so we can get a little start on this unit conversion and then probably Thursday sort of finish it up, okay? Y'all ever done unit conversion? I bet you have.
Time.
You ever turned inches into feet?
No,
Have y'all ever figured out how many inches was in 2 feet?
no.
And then in chemistry.
Yeah, chemistry, y'all do a lot of conversions.
Chemistry.
Y'all probably ain't done too much of the kilometer, mile type stuff. All right, we all got to get good at it. Because in America, we're Fahrenheit people, right? If you go overseas, guess what? They're Celsius people. But we got formulas that can convert from either way. I think we're in the feet, inches, and all that kind of stuff here. Over the feet, they're in the meters and grams and all that metric stuff. Okay?
Metric system.
I think we're one of the few left on the English conversion stuff or whatever. All righty, so, oh, we're gonna go. Here we go. So unit conversions. And really, I'll tell you what, if you learn what units are, you can figure out formulas in them science classes. Like miles per hour for speed, miles per hour. What does miles represent? Distance, hours. So I know that the formula for the speed would be the distance divided by the time. And that's what's nice about units. You can sort of use them to figure out them hard equations, okay? But you know, on here, we're going to convert numbers from one unit to another unit. So I do these with like lines and little vertical lines so they can show you. So we're going to convert 2 feet into inches. One come in. And this will be the sheet I'll send out in an email later, the one I gave y'all in class. If you don't know the inches to the feet conversions, that sheet I gave y'all should have all that on there. But we do know what? How many inches is in a foot? 12.
12.
So I know that there's 12 inches equals 1 foot, right? So I'm starting out with 2 feet. So I'm going to start over here, y'all, and write down my 2 feet. And then I'm going to draw a line like that and a line like that. So I want to cancel out these feet and turn them into inches, right? So watch what I'm going to do. I know that for every 1 foot or 1 feet is how many inches. So you see how I'm going to cancel out these feet? But here we said 1 foot was 12 inches, right? So what happens to my feet now? Huh? I'm going to cancel them feet out. So the only unit left is my inches. And what they want me to turn it into? Inches. Now, everything on top gets multiplied. Anything on bottom would get multiplied. And then my final step would be to take the top, divide by the bottom. Am I worried about that 1? Because anything divided by 1 is basically going to be itself. So let's see, all we got to do is take the top and multiply. So 2 times 12 will give you 24. The feet canceled out, so the only unit left is my inches. So y'all, is there 24 inches in 2 feet? Sounds good, right? This stuff ain't too bad. So if that makes sense, how I'm sort of setting them up, and then you want to sort of cancel out the units you don't want, so it brings in the ones you do, okay? 4 grams into milligrams. So convert 4 grams to milligrams. So grams will just be what, a G, and milligrams will be a little m and a G, okay? And that should actually be on your sheet. The metric stuff is in the bottom left corner down here. Now remember, grams, meters are all the basic units. So on here, they're dealing with the distance with the meters, but where they got an M, you treat that like a G. So I want to go from grams to milligrams. So let's see. I ain't seen that, you know. I think that might be on the homework pages.
Okay.
All right, let me give you a quick refresher on the metric system. How about that? So before we do that, I'm going to do a little metric system here. So in the middle of your metric system, you got your base units. Your base units would be the meters, grams, seconds, I got distance, weight, time, okay. Now, this metric system goes two ways. I can go up, increasing by powers of 10, or I can divide by those powers of 10, okay? So going below the meters to the division of the 10, oh, what's first is a decimeter, okay? So this would be like, so if this was 10 to the 0, this would be like 10 to the negative first. You would just divide by 10 and get that, okay? What's smaller than a decimeter? It's more common, centimeter. Which is a 10 to the negative second. And then what's next? Millimeter. Which is 10 to the negative third. All right, so we won't worry about going too much deeper, but they do got stuff like micro and nanos and all that crazy stuff. Going upwards,
Like what I'm doing.
you got a, oh, how do you spell it? I think it's like this. Decameter? Might be a C, I'm not sure.
That's how you spell it.
Next, you would have a hectometer. And those are actually on here, ain't they? So that's going down. Where's the one going down? Oh, so Deca was a DECA, so let me fix that. Hecto, okay, so I didn't do this. 10 to the first, 10 to the second. So what's after the hecto? The one y'all are probably the most familiar with. Oh, what about the one with K? Kilo. So what this means, 10 to the first means if you started with a meter, a decameter would be 10 meters. A hectometer would be 10 to the second. Well, 10 times 10 is 100. So 1 hectometer is 100 meters, okay? Kilo is 10 to the third, which is 1,000. So 1 kilometer is 1,000 meters. Going this way, this would be like 1 over 10, this would be like 1 over 100, and then 1 over 1,000. So you multiply this way, but then you're really dividing this way. So there's 10 decimeters in a meter. There's 100 centimeters in a meter. And then there's 1,000 millimeters in a meter. Which means from here to here would be the difference of a million. Between a millimeter, there must be 1,000,000 millimeters in a meter. Okay. So notice, they wanted me to go from grams to milligrams. So, would y'all believe that there would be 1,000 of these milligrams in every gram? Right? So 1,000 milligrams is going to equal 1 gram. Y'all with me? There would be 100 centimeters in a gram, and there would be what? 10 decimeters in that gram. Up here, you would have to go, there is 10 meters in 1 decimeter. There would be 100 meters in a hectometer, and then there would be 1,000 meters in a kilometer, okay? So I do know that 1,000 milligrams is 1 gram. So watch what we're starting with, the 4 grams. And remember, we're just getting a start today on this part of it, okay? So, I need to cancel the grams, so the grams has to go to the bottom. The 1 gram is going here. So right here, I'm gonna put
1,000.
oh, what y'all say online?
1,000.
Yeah, that's gonna be the 1,000 milligrams. So that your grams cancel. Now, don't it make sense? There better be a whole lot more milligrams than there were grams when I started with this, right? Well, here we go. Nothing on bottom other than a 1, so we're good to go. So we're gonna multiply the top 4 times 1,000. Gives me 4,000, and the units would have to be
Milligrams.
milligrams. There you go. Okay, so it's not too bad. You just got to get the conversion you need for those, okay? There's only the one y'all all know. And this probably my last one for today. We're going to convert 4 hours into seconds. So I'm going to start over here with 4 hours. Now, do you know how many seconds is in an hour? If not, I do know there's another unit that's within that hour that I could use. I don't know how many minutes is in an hour, right? What that would be. So watch this. For every 1 hour, there is 60 minutes. But look, the hours are canceled, but they didn't want me to end up in minutes. They wanted me to end up in seconds. So is there a conversion I can go from minutes to seconds? So every minute is 60 seconds. So you'd have to do this again, draw another line over here. And 1 minute was 60 seconds. Now my minutes are going to cancel. And I'm going to end up with my seconds. So, one of y'all got a calculator for that. Do it now. I'm going to multiply the 4 times the 60 times the 60.
That's correct.
And that'll be correct. Remember, seconds is a multiple.
Are you multiplying those?
Right? So 60 times 60, that's like 3,600 seconds in 1 hour.
14,400.
So 14,400 seconds, right?
Did you multiply that, sir?
Yes, ma'am, we did 4 times the 60, and then that answer times the other 60.
Okay.
And you would really expect this to be a lot bigger for seconds versus hours anyway, right? No, just in minutes, that would have been 200 and something minutes, right? For 4 hours, 60 minutes an hour, 60, 120, 180, 240 just in minutes. And then 240 minutes turned into 14,400 seconds, okay? All right, so don't stress over them too bad. We're just getting a start on those. And I'll send out that sheet again for y'all later in an email. Most of y'all didn't got it in here, so you wouldn't have to print it again. Okay. Right, question?
No.
Oh, was that real bad? It wasn't too bad, was it? Well, you like the fractions, you said.
I have a question, Mr. Rethon.
Yeah, I hear you.
On your examples up here for the convert 2 feet into inches, the ones on top, will you always multiply them to get
Yes.
your answer?
Uh-huh.
Okay.
So, and watch this. Anything on top gets multiplied to get a big number. if you had stuff on the bottom, all that would get multiplied, and then the final step would be to divide that top by that whole bottom,
Okay.
okay? But we've been looking out and just had a bunch of ones on the bottom, so that's sort of been helping us out. All right, so any of y'all staying in here for support lab? So y'all gonna be ready for me Thursday, I bet, right? So what we'll do, y'all can probably get a little bit of a start on the homework, but I haven't gone too deep into the conversion. If you're doing support, I think the main support stuff was doing the fractions and some of those exponent rules and stuff, okay? So work on those. We will do Thursday. I'll finish out the 2 ABC stuff. Go through all the conversions because they got problems with money, distance, time, all kinds of stuff, okay? So we'll knock them out. Y'all, the main thing online and in here, if you haven't done the course agreement quiz, y'all got to get that done by Sunday night. Because after that, they're going to drop y'all out, okay? So, I think, so you're good to go. It wasn't bad, was it? I agree. So you're good to go. So let me mark you off.
What are you doing? Where's my mouth? Come here. Ichabod. What are you doing now?
It was Colton, right? Okay. Anyone got any questions? Questions online?
No,
Was y'all able to hear me
No.
today?
Yes.
I hear you.
Okay, so
Uh-huh.
I'll send out a video for y'all later on if y'all need it, and then I'll see y'all Thursday.
Thank you.
All right, y'all have a good day online.
Thank you.
Yeah.
You too.